Hello and welcome to today's lesson on distance time graphs. Our learning objectives are to relate the motion of an object to the line on a distance time graph, describe what the slope of a distance time graph tells you, and use the distance time graph to calculate speed. I'm going to start off by asking you to sketch a series of graphs. These don't have to be particularly neat and you can do them in the back of your book. To start with, I'd like you to sketch the distance time graph for a car travelling at a constant speed. You can pause the video at any time to give yourself more time. A car travelling at a constant speed would look something like this. The gradient will depend on how quickly the car is travelling. You can find out the exact speed that the car is travelling at by calculating the gradient. What would a distance time graph look like for a car that's stationary in the pit lane? This distance time graph shows you a stationary car. You can tell it's stationary because the gradient is 0 and that the distance doesn't change throughout the time period. This graph also shows a car that's stationary in the pit lane. The car is not moving and the gradient is 0. I'd now like you to sketch the second half of this graph, showing the car travelling at a faster speed than it was for the first half of the graph. And here you've got a steeper gradient for the second half of the graph, showing a faster speed. I'd now like to ask you to show a car that's constantly accelerating. So think about what's going to happen to the gradient of the car as it gets faster and faster. And here you can see the gradient of the graph is continuously getting steeper because the speed of the car is getting faster and faster. The gradient of a graph where time is on the x-axis tells you about the rate of change with time. For example, if it is a distance time graph or a displacement time graph, the change in distance over time gives you the speed, so the gradient gives you the speed for a distance time graph. To find the speed from a distance time graph, we need to draw a right angle triangle under the line and then find the change in distance and the change in time for that right angle triangle. Then we use the equation speed is distance over time to calculate the speed. Here is an example of a distance time graph, and all you need to do is find the speed of the object. To find the speed, we need the change in distance divided by change in time, which will be the same as the gradient of the graph. Remember that speed is just distance over time. To find the gradient and therefore the speed, we need to draw a large triangle. This triangle has a height of 3,000 meters and a length of 120 seconds. To find the gradient, we'd use distance of 3,000 divided by a time of 120, and it will give us a gradient equal to the speed, which in this case would be 25 meters per second. It's important that you can distinguish between a distance time graph and a displacement time graph. Distance is a scalar quantity where direction doesn't matter, and so distance will always go up. In contrast, displacement can have both positive and negative values because it is a vector quantity, and so direction matters. Here we have both a distance time graph and a displacement time graph for the same journey. Hopefully you can see the difference between the two. That brings us to the end of today's lesson. I hope you found it useful, and thank you very much. Here we have a distance time graph for a woman who's gone for a run in the park. The sections are labelled A to E. The time is measured in seconds and the distance is measured in metres. During which section of the graph was the woman not moving? While you work it out, pause the video. The answer was section C. During which section of the graph was the woman travelling the slowest, not including C, which we've already covered? Section E has the shallowest gradient and therefore has the slowest movement. Describe section D of the journey, including the distance travelled and the time taken. In this section of the graph, the jogger travelled 200 metres in 40 seconds. I'd now like you to write a paragraph to describe the woman's journey. You can make up reasons for her change of speed as you go along. Don't forget to pause the video at this point so you can write the paragraph. Here we have an example answer. To begin with, she is running relatively quickly and then slows down and then stops and then starts running again relatively quickly before finally slowing down for the last part of her journey. And now I'd like to find the woman's speed over section B. Remember, it's the change in the distance divided by the change in time. So the change in distance is 400 metres, the change in time is 100 seconds, so 400 metres divided by 100 seconds gives a speed of 4 metres per second. Now I'd like you to draw a distance time graph for the journey of a remote controlled car using the information provided here. If you have graph paper, then please use that, and don't forget to pause the video while you're plotting the graph. Your answer should look something like this, with time on the x-axis in seconds and distance on the y-axis in metres. Make sure your graph is covering at least half the page. Now I'd like you to calculate the average speed for the car for the whole journey, and also use your graph to estimate the time at which the car has travelled 8 metres. Pause the video while you find the answer to these two questions. The total distance divided by the total time should give you a speed of 0.625 metres per second. and after 14 seconds the car will have travelled 8 metres. Well, that brings us to the end of today's lesson. I hope you found this useful, and thank you very much.